Hey, how you doing, superhumans? Welcome back to our new lecture. And in this lecture, we will be discussing the first type of ICMP message, that is time limit exceeded. You must also already have covered about TTL in your previous lectures, but I want to give you a little more depth about what TTL exactly means, because a lot of students are confused about how TTL exactly works. So, with this time limit exceeded message, what is exactly the working of TTL, even the TTL field inside the IP datagram, that would also be clear to you. Okay, now TTL value of an IP packet is decremented by 1 at each node. So first let's understand what is TTL. Let's say that this is the sender, this is router 1, this is router 2, this is router 3, and then this is the final destination. So I am showing it as D. Okay. Now I've sent a particular IP packet. This IP packet will be having a field which inside this IP packet, let's say that this is an IP packet. Inside this IP packet, a lot of things are there like IP header, IP data. Then let's say that I should not have used that word let's say, but there's a field, TTL field inside this IP packet, which tells the number of hops that a particular IP packet can take. So for example, let's say that the TTL field right now when I'm sending this packet is 2. So how this packet is going to move about through these routers, it's somewhat like this. When this IP packet is starting from here, this packet looks like this. When this packet reaches over here, this IP packet, this same IP packet is looks somewhat like this. TTL is equal to 1. So as you can see that the value of TTL inside the TTL field has been decremented by 1 by this router. Now if the TTL value is not equal to 0, this means that it can take more than 1 hop, at least more than 0 hop. So it, or I should be using the word, at least it can take 1 hop. So now it is going to take 1 hop. When the packet reaches over here, so the IP packet has the TTL value inside the TTL field as 0, because at each hop the value of TTL is decremented by 1. This is what we have studied in the first pointer. Now when the packet reaches this router and it sees that the value of TTL is 0, what is going to happen? Now you would be asking me in what step the value of TTL field is decreasing. It decreases somewhat like this. First, this packet with the TTL value 1 reaches here. Then this R2 is going to decrease the value of TTL to 0. So then this is the first step. We can call this as the second step. The first step is when this packet reaches over here with the TTL value is equal to 1. Then this router R2 is going to decrement the value of TTL to 0. Now what would happen is, since the value of TTL is 0, this means that this particular packet cannot take any further hops. Since it cannot take any further hops, so this router R2 is going to discard this packet. Since this packet is discarded, so now this router R2 is going to send an ICMP message back to this sender of the packet that I have discarded your packet, and the reason for the discarding of your packet is that TTL, that the time has exceeded. So this ICMP packet will look something like this. Since the type number for the time limit exceeded field is 11, so ICMP packet will contain 11. Then if the packet is discarded by some node in between and not by the final destination, then we can say that the code is 0. Okay, and then there is checksum over here. I hope that till this point things must have been very clear to you. Also, I want to make one more point. That point is that if TTL becomes 0 at any node, by any node I mean by any router or any switch that is there in between. If TTL value becomes 0 not at the destination but at the router, any of the 1 routers, then that particular router is going to discard that packet. Now how is TTL going to become 0? First, the packet will reach the router, then router is going to decrement the value of TTL, and then it sees that is the decremented value of TTL greater than 0 or not. If the value of the decremented TTL value, for example, when this IP packet reached over here, it had a TTL of 1, but after the router R2 decremented the value of TTL to 0, it checked that the value is not greater than 0, so I have to discard the packet. What I'm trying to say over here is, the first thing is packet is discarded only when the TTL value is 0. The second thing is packet arrives at the router, then the router decrements the value, then it checks if the value of TTL is greater than 0 or not. Only after that, after it checks that the value of TTL is not is not greater than 0, then it is going to discard the packet. And the third point is that this can only happen at one of the nodes like routers or switches. This can never happen at the destination. This is case 1. Let's say the case 2 is within the same here. Let's say that this is the sender, this is router 1, this is router 2, this is the destination. Now let's say the IP packet is sent with the TTL field as 3. So when the packet reaches over here, the TTL becomes 2. When packet reaches over here, TTL becomes 1. Why? This packet, when reaches over here, it has got the TTL value of 2. TTL is 2 when this packet reaches over here. But then this router 2 is going to decrement the value of this TTL. So the value got decremented, and then this router R2 is going to check whether this value, decremented value that I have decremented, is it greater than 0 or not. If it is greater than 0, then it again is going to forward that packet further. When this packet reaches over here, this packet, initially the value of TTL is 1. Then this destination is also going to decrement the value of TTL to 0. Now since the value of TTL has become 0, but since it is not a node, so the destination is not going to discard this packet because of the number of hops that the packet could take, because TTL shows the number of hops that an IP packet can take. So the destination is not going to discard the packet due to the reason that the number of remaining hops is equal to 0. This packet won't be discarded because of this reason. TTL field basically tells about the number of remaining hops after the value is decremented. When the packet reaches over here, after the value is decremented, this decremented value tells the number of hops that are remaining with this packet. Okay, we have covered the third point as well, that when the value of TTL becomes 0 at the destination, then the packet will not get discarded. Okay, but now you would be thinking one more thing, that how would the sender know about this thing, that what value of TTL should I send? So it will check something like this. When router R2 is going to send the message that I am discarding the packet and the value of TTL is 0, because of this reason only I have discarded the packet. So when this packet reaches, ICMP packet reaches the sender, it sees that the reason for the discarding of the packet is TTL, and it is coming back from the router. This 0 tells that the packet has come from the router and not from the destination. So the next time it is going to send the router, the next time it is going to send the packet, IP packet, it is going to send with an increased value of 2, with an increased value. That value will be 32. Okay. Now, even if with this TTL of 32, when this IP packet with the TTL of 32 travels, let's say the case 3, this is the sender, this is router R1, this is R2, and then there are number of routers, then this is router N, this is the receiver, or you can say the destination. When the packet travels and it keeps on traveling, I should have made it something like this, keeps on traveling, and then finally it reaches some router where the value of TTL becomes 0. The value of TTL has become 0 over here, not because there were a lot of routers, but because of this reason, that First, this packet went from, let's say, some router J to some router I. Then this packet went to some router RK. Then this packet is going to some router RJ, and like this it is forming a loop. The packet has got stuck in the loop because of this. Even when the initial value of TTL, when the packet was sent, when the initial value of TTL at that moment was 32, even then at some router the value of this packet, the TTL value of this packet becomes 0. And when the sender receives an IP message, for example, let's say the value of TTL becomes 0 at this router, then after this router, then this particular router is going to send an ICMP message to the sender that the packet has got discarded because the value of TTL is 0. Or I can say that the message says simply that the time has exceeded, because of which I have discarded the packet. Now the sender is very much sure that the packet has got stuck in some loop. The IP packet that I am sending, it is getting stuck in some loop, because of which even the value of, even when I sent the TTL value of 32, that value is finally becoming 0. So this means that the packet is getting stuck in some loop. So next time I am going to send the packet, I am not going to send the packet through the same route. For example, let's say I'm making the case 3 more clear to you so that it becomes really clear. This is R1, R2, then this is RJ, RI, and this is RK. The packet reaches here, then packet reaches here, then it reaches here, then it reaches here, then it reaches here, then it reaches here, and over here it is forming a loop. So even if the value of TTL is 32 over here, then it becomes 31, 30, this becomes 30, this becomes 29, 28. When packet reaches here, it becomes 27. When packet reaches over here, the new value of TTL, the new value of TTL that the packet would be having would be 26. Now when this packet with the TTL value of 26, when this packet reaches this router again, the new TTL value of the packet would be 25. And like this, there would come a situation when finally the value of TTL will become 0. Let's say the value of TTL becomes 0 somewhere here. Then this router is going to send, or let's say the value of TTL becomes 0 over here. So this router is going to send an ICMP message back. Now, if this ICMP message reaches the sender, then this means that TTL value has again become 0 because of the time limit exceeded, and that has been done because the packet has got stuck in some loop. So next time the sender is not going to follow this loop, not going to follow this path. It is going to follow some other path which is having some routers R1, R7, R8. Okay, this must be very clear to you. Now the last point of this is that although I have said that the router, the sender won't be getting an ICMP message of time exceeded from the destination because of the number of hops, but I have not said that the destination won't be sending any ICMP packet back, or I have not said that the destination cannot send an ICMP packet back of type time exceeded. It can definitely send, but the reason won't be the number of hops. The reason would be something else. So let's see in what cases the destination can send the ICMP message back of type time limit exceeded or time exceeded. So let's say this is sender S and this is the receiver, this is the destination, and there are a lot of fragments of a datagram. So this is the datagram, and this datagram has been fragmented into a lot of fragments. And let's say that the time limit in which these, okay, I won't complicate it right now. These fragments finally reach, this is fragment 1, this is 2, this is 3, this is 4, and this is 5. The one reaches this fragment 1. When this fragment 1 reaches the destination host starts the timer. So it starts the timer, this is start the timer with the 0 seconds. And now the timer the time in the timer is going on, and let's say packet 2 reaches over here, packet 3 reaches over here, packet 4 reaches over here, then the when till the time when packet reached over here, when packet 4 reached over here, the time at that point was 40 seconds. Let's say, let's take some case that packet 4 reached the destination at time 40 seconds, and this datagram was to reach the destination within 40 seconds. Within 40 seconds. So let's say that if all the fragments of the datagram reach the destination within 40 seconds, then the destination is not going to discard the fragment and it is not going to send an ICMP message back. But if any of the fragments is lost somewhere in between and is not able to reach the destination within this time frame, which is 40 seconds, I am just taking an example of 40 seconds. That time frame can be any value. Just this is just an example. That value can be 10 seconds. That value can be in milliseconds as well. That can be anything. Depends upon the situation. What I am trying to say over here is, if any fragment reaches the destination after this time frame, then that fragment will be discarded. Also, an ICMP message will be sent to the sender that I am discarding the packet because of the time exceeded. This time exceeded does not mean the time exceeded of time to live exceeded, or that the time to live value has become 0. What I mean by that is that the fragments were not able to reach all the fragments, the complete set of fragments of a particular datagram were not able to reach the destination within a particular time frame that was set by the situation that was given for the fragments. So the ICMP packet will be sent, and this ICMP packet will be containing the type field will be having value 1, and then in the code field, since it is discarded by the destination and also because the fragments could not reach the destination within a particular time frame, so because of, if that is the reason for the discarding of the packet, then the ICMP packet will be having the code 1, and then there will be checksum as well. I hope that this much is very clear to you. With this, I'm going to end this lecture after giving you a very quick summary of the complete lecture. The first thing that we studied over here is, what is the meaning of time to live? Time to live, the basic meaning of time to live, TTL. I'm not talking about the ICMP message that is containing the time exceeded message. I'm not talking about the ICMP of type time exceeded. I'm talking about TTL value. So TTL value merely tells about number of hops that a particular IP packet can take. The remaining number of hops, you can say. The second thing that we studied over here was the value of TTL decrements by 1 at each hop. And the third thing that we studied over here was that time exceeded message is sent in two cases. If it is sent by node, then this means this message, this ICMP message with the time exceeded and with the code 0 and type 11 is sent because the number of hops, remaining number of hops, have become 0. Or I can also say that the value of the TTL field has become 0. Then there could be another case that the time exceeded ICMP message is sent, that is sent by the destination. This message, when the TTL value becomes 0, can only be sent by the node. When the destination sends the message, that is because all the fragments were not able to reach the destination within a set time frame. All the fragments couldn't reach within set time frame. That time frame depends upon the situation, or that time frame can have different values based on the different situations or based on the different datagrams. What I'm trying to say is, whichever packet reaches the destination after the set time frame, then that packet, that IP packet will be discarded, that fragment will be discarded, and an ICMP message with the type 11 and code 1 will be sent back to the sender, telling about the whole situation. this is what we have covered today. I hope that the complete knowledge of what TTL means and what is time exceeded and in what cases do we send the time exceeded message is pretty much clear to you. Bye.